Hello and welcome to another creative coding video. Today we're going to be looking again at colour, but we're going to be learning about a new way to mix colour. You'll see why the previous way wasn't always very helpful and how this new way can help us, particularly if we've come from an art or design background. What we learned before, and you can go back to the earlier video if you want to have a look at that. What we learned before was about mixing colours using red, green and blue lights. Why those? Where did that come from? Well, that model of mixing colours really comes from the way colours are displayed on your monitor, on your television, on your smartphone, on your tablet. So most electronic displays have tiny little red, green and blue lights, and they turn on and off or vary the intensity, and by mixing those red, green and blue lights they create the impression of a colour. Now we did that before and it was quite fun. We could certainly pick colours by name, but we found that by mixing colours, by using numbers to represent the different levels, we had greater control and we could do calculations, which was quite fun, and you could create some interesting designs based on the fact that you could calculate the colours and use maths functions, for example, which we saw last time. This website we've seen before. It's a colour mixer. You'll find colour mixers everywhere in your favourite image editing program or online like this if you want to have a look at this one. And just as a reminder, if there's lots of red light and no green and no blue, we obviously get red. If we start mixing in a bit of green, we get yellow. Now that's not intuitive. If I said to you, what are the red, green, blue, the RGB values to make yellow, it wouldn't be immediately obvious. Red is just 255 red, 0 green, 0 blue. Let's do that. You can see 25500 is red, and that's the kind of code there. 25500. Those are just other ways of writing it. If I said green, obviously that's maximum green, and no red and no blue. But if I said, well, what's yellow? If you hadn't already seen it, it wouldn't be obvious. It happens to be red and green mixed together to give us yellow. That's not obvious. If I said, well, I want orange, or I want a way of calculating all the colours between this yellow and an orange, it's not obvious how to do that. What is orange? I don't know. Is it? Oh, I just struck lucky there. It's less green, but again, that's not obvious. So the red, green, blue, the RGB colour model is useful, but it has its limitations, and its biggest limitation is that it's not obvious how to get a colour you want. You have to kind of play around or look at a colour mixer to help you do that. Now let's look at another colour model, another way of mixing colours, which is actually quite popular. It's perhaps not so well known, but amongst digital artists, algorithmic artists, designers, they're more aware of it, and I hope you'll love it actually once you've seen it. This alternative one has a name, which we'll come to, but we shouldn't really focus on the name. It's more important to understand how it works. So what we're looking at on the screen appears to be a colour wheel, and we've got colours that go around the wheel. We've got a red there, orange, greens, blues, purples, and all the way back down to red. Now, colour wheels are something many of us are familiar with, and this new colour model actually does use a colour wheel, Once you become familiar with the wheel, you start knowing where the colours are. So the first thing you'll probably get to know is red is always at the 0 position. You can see a good way of describing where the colours are is how far around the circle they are, and it's common to use the angle in degrees or other units. So red is at 0 degrees. So if I go 90 degrees round the circle, I arrive at 90 degrees at the top, which is a green. If I continue round to 270 degrees, which is 3/4 the way around, I have this nice deep purple, and then I start moving back around to red again. Now where's yellow? Well, I haven't filled in all the colours on this colour wheel. Maybe I should show that. Maybe I should show a picture of the colour wheel with more colours filled in. And this is the colour wheel with more of the colours filled in. And you can see that at the 0 position we've got red, and as we move around, increase the angle, we move through reds that become oranges, which become yellows, and yellow actually is at this particular pure yellow is at 60 degrees. I think that nice orange is at 30 degrees. And then we have a nice green at 90 degrees, and as we move around, we move through cyan and the purpley violety colours back round to red. Now on other colour wheels you might see red at the top or the left or the bottom. It's convention to put it on the right, but it doesn't have to be. The important thing is that in this colour model, 0 degrees is where red is. So they might start 0 at the top or on the left, but I'm starting it here, and it's quite common to do that. Okay, so how do we use this? Well, let's go back to that picture we were looking at. We need a way of describing these colours. We can't use red, green, blue values anymore because this is a different colour model. We need some other numbers. Well, actually we could just have the angle, and that would work, but this colour model also has 2 other numbers that describe how intense the colour is, the saturation, and then also how bright the colour is, how light it is or dark it is. So let's look at this picture and vary those brightness and saturation values. So in this picture you can see I've got a saturation of 100% full on and a brightness of 100% full on. In this next picture, which is very similar, you can see that this time I've got saturation of 50%. So if I looked at the red, it's now not so intense. It's almost as if it's like watercolour paint diluted with more water. You can think of saturation as the concentration of pigment in water. So you can see the oranges are much more watery now and not so intense in terms of their colour. And that's happened to all the colours. Let's flip it back and forth just to see that. Do you see the blue going lighter? Well, not lighter, less saturated. Now let's compare that with another picture where I've turned the brightness down, not the saturation but the brightness. Let's go back to the default and compare here. Okay, let's focus on that red. So that's a bright intense red, and it's still an intense red. The saturation is still 100%, but the brightness is now reduced. It's almost as if I've turned the lights down. So you can see that we have 3 controls now, 3 buttons, 3 knobs we can twiddle. We've got the degrees around the circle, which tell us which colour, which hue, and that's the actual word we should be using, which hue we're picking. Is it red? Is it a blue? Is it a green? And then once we've picked a colour, how saturated do we want it to be? That's the second dial. And the third dial is the brightness. Do we want to turn the lights down to make it darker? And between those three knobs, those three controls, we actually can recreate and mix quite a large range of colours. I think technically there might be some that you can't, but that's going way super advanced. But for practical purposes, this is a very good colour model. Let's try actually using it. We've talked a lot. Let's have a go at coding. So let's go and set up a sketch like we always do. I'm logged into Open Processing as usual, or turned on the, where is it? There it is, the simple.js library, and I've enabled it in the setup section. Now here you'll be very familiar now with these instructions. I've used the fill instruction just there to choose red, and I'm drawing a circle in the middle of the canvas, size 200. We've done this so many times now, it's very familiar to us. And as if I run the code, you will not be surprised, there's a red circle. Brilliant. And you also know that if I used the red, green, blue, the RGB color model, I can choose red like this. Red is full, green, blue are 0. That will also give me a red. And of course I can fiddle with the other numbers, I don't know, to give me a different kind of colour. Oh, that's nice. How do I switch to using this new colour model? Well, this new colour model has a name, and it's called the HSB colour model. Let's go back to that picture. H for hue, which is the colour we're picking, the hue we're picking. H. S for saturation, B for brightness, HSB. And we choose it in our setup section. We say color mode HSB. That's it. You might prefer to choose color spelt like that. I prefer the local spelling. And again here in the fill instruction, we're going to be picking 3 numbers. What are they going to be? Let me just put placeholders. Well, the first one actually is actually H, the hue. The next one is saturation, and the next one is brightness. So that's not surprising at all. Now, what are they going to be? What are those numbers going to be? Well, if we think back to our RGB color model, the colors, the red, green, blue lights, all went from 0 to 255. They don't do that in the HSB color model. H, the hue, which is the angle, goes from 0 through 90 degrees, 180, 270, all the way up to 360 degrees. So the first number, the hue, goes from 0 all the way up to 360. Let's pick 0 because that's red. The red hue. Saturation, and these again could go from 0 to 1, but they, in this by default here, they go from 0 to 100. So let's say saturation is 100 and brightness is 100. Let's see what happens now. What do you expect before we run the code? 0 is red, full saturation, full brightness, so I should be getting that colour there, this really intense bright red. Let's see if that happens. Yep, it did happen. Let's change our code and let's see if we can find that yellow. Was it at 60 degrees? I think it was, wasn't it? Did I have it over here? Yep. I think it's 60 degrees. Let's change our, lost the picture. Let's go and change that to 60 degrees. There we go. Yep, yellow. Now this is much nicer than having to work out which red, green and blue values make yellow, because we've now got all the colours on the colour wheel. We don't need to think about mixing odd amounts of red, green, blue to make yellow. We've got the colours that we want, all of them are on here, and then we can vary how bright or how saturated they are, but we start with all the colours. So if we wanted some kind of brown, it might be something like an orangey starting point and then getting darker and maybe moving towards the yellow, so we'd increase the angle a bit. So you can start to see how this different colour model, it makes us think differently, but that different way is actually much more intuitive, certainly more intuitive than trying to think which red, green and blue lights are going to mix to give us the colour. Let's try again. Let's see if we can find this nice blue here. So that's 180, that's 270, that might be 220, I don't know, let's see. Let's have a go. You should experiment yourselves. Yep, that's a nice blue. And if I wanted that one at the bottom, the one that was much more purpley there, 270, which was at the bottom. Okay, so we've now practiced how to enable this color mode called HSB color mode, and we've worked out how to pick a color. What we haven't yet done is played with the saturation and brightness. So let's pick that red again. I like that red. Let's see what happens if we turn down the saturation. We know it should be a less intense red, as if it's had water added to it. Let's bring that back up to 100, and let's turn down the lights. Let's make it darker. Yep, that's definitely a brown. Great. Let's do the experiment that we wanted. How do we make a different kind of muddy brown? Let's start with an orangey kind of colour, which on the colour wheel was not quite as 60 degrees, maybe 30 degrees. So that's 30, let's start there. Yep, and now let's make it darker. So let's turn the brightness down. There, a brown. So you can see already with this example, it's much more intuitive to work out the colours you want in this colour model. That's not the end of the story, there's more to do. But if you wanted a pause, this is a good point to have a pause and experiment and play. Have a play with picking different hue values for the colour, saturation and brightness. In fact, I think it's worth drawing a few of these circles just to compare visually the effect of those different saturations and brightnesses. So I'm going to copy and paste this code. So I'm going to start with, say, red. Should have done that before I copied it, shouldn't I? Bit of quick typing there. I'm going to draw first a big circle of size 300, 200 and then 100, and if I do that I'll just get 3 circles the same. Now what if the second one I turn down the 50, the saturation 10? We should be able to compare them more easily. You see? So this one has got, they're all the same hue. All these 3 circles have the same red at this 0 degrees. It's the very same red, but the difference is a change in the saturation. So full on saturation, less saturation and even less saturation. Everything else is the same. It's pretty amazing, isn't it? Let's bring those back up to 100 and let's experiment with the brightness. Let's change that to 70 and 50. There you go. Again, the important point is these are all the same hue, the same red as the starting point, but then the brightness is turned down. Now, you might have realized looking at this that this is a great way of calculating colors that are variants of a base color. So picking a red or a green or a blue, and then working out, calculating darker versions of it or lighter versions of it. And that's really, that is incredibly useful. It's one of the most beneficial things, one of the really good things about this color model, which is why it's so popular. You might have started this video thinking, why is this useful? But you'll start to see that it's not just intuitive. The calculations it allows us to do are really useful. Let's kind of put that into words. Let's pick a color. Let's say var hue. Whoops, shouldn't be pressing capital letters there. Var hue equals random number between 0 and 360. So that picks a random number, and then I'm going to draw those circles with whatever random hue it picked, but we'll be varying the let's change the saturation. So you'll pick a random hue. Okay, it's picked a purple, and you can see those are the calculated variants of it. Let's run it again. Yeah, it's not so obvious this time because yellow is quite a light colour anyway. Yeah, you can see it there. Running it again. It's more apparent with some colours, isn't it? This random colour thing is picking green a lot. There you go. So that's a nice sort of yellowy orange, and those are less saturated versions of it. And the same there with this kind of green, which is slightly bluey in tinge. This random number generator today is picking a lot of greens, isn't it? There you go. A nice sort of pinky purple with versions of that colour which are less saturated. So that's a nice experiment, isn't it, to see how you can do a very simple calculation. We're not even calculating, we're just simply picking a random hue and then calculating the other two, picking the other two versions of it. Let's fiddle with the brightness. So let's say 70 and let's say 50. There you go. So it started off with an orangey colour, and then we worked out darker versions of it. There you go. Greens, yellows. That's quite effective as well. So that's really nice, isn't it? Okay, so have a pause there if you'd like. We're now going to move on to something else that we can do with our colour model. So let's bring up another picture. Here I'm looking at my colour wheel again, and I've drawn an arrow from one colour, one hue, to the one that's directly opposite. And what do you notice? Well, you can see that they are opposite colours. So you know, particularly if you've kind of had some experience with colour theory or art, this concept of opposite colours, complementary colours. So here, this deep blue is the opposite of yellow, and when they're placed together they clash because they're very opposite in nature. The same with this kind of green, this kind of magenta colour. Over here we've got this cyany colour and red, and they're opposite. And looking at it this way, on this colour wheel tells us that we can calculate opposite colours. How is that? Is that surprising? Is that a shock? Well, if we've picked a colour first, let's say we've arrived here at 60 degrees, so we've got one number, 60 degrees. To find the colour or the angle that's opposite on the circle, we move around it by half a circle, which is 180 degrees. So we add 180. So 60 plus 180 is 240. If we started with red, which is 0, add 180, we'd go whee all the way around, 180 here. If we had 90 and added 180, we'd go whee, we'd end up here. So adding 180 degrees to a colour takes us to the other side of the circle, the opposite side, and we land on the complementary colour, the opposite colour. Let's experiment with that in Encode. So what we'll do, we'll first start simple. No, we won't. We'll pick a random hue, and we're going to say we've picked a random hue, which could be anywhere on the circle, and we're going to say the opposite hue is hue plus 180, and then we're going to say fill with that. We'll draw two circles. We'll draw a big one with hue, and we'll say full saturation and brightness, and we'll draw a circle 400, 300, 300, and then we'll draw another one inside it with the opposite colour hue, and we'll draw it smaller. Let's see if that works. Kind of. The reason it didn't work, see, the middle's always kind of red. The reason it didn't work is if I picked, let's say, if this picked 10 for hue, then 10 plus 180 is 190, then that would work. But if this initial hue was already, let's say 270, adding 180, I can't do that calculation in my head. I'm gonna cheat and use a calculator. My brain's gone. Plus 180 is 450. But we said the hues only go around from 0 to 360. So what is a hue of 450? Well, different coding languages will treat that differently. In this one, it kind of seems to be just sticking and back to red. So we need a way of bringing that back down. And the way to do that, and we have seen it before, is to use the remainder instruction, this one here, %, 360. Now some people call that a modulo function, and in some languages it is. In this particular language, which is JavaScript, it's actually more strictly a remainder function. What it does, it says I'm going to, whatever number I've got, I'm going to divide it by 360, and whatever's left will keep. So you can see that if my sum, hue plus 180, was 270, then dividing them by 360 and keeping the remainder will give me 270 again. But if I had a large number, 450, then 450 divided by 360, keeping the remainder, would wrap me back around that circle again. So you can see that here, if this was 361, this would give me the remainder after dividing by 360, which is just 1. Is that hard to understand? Is that complicated? let me draw some pictures. Pictures always help. Right, so 5, 2, so 5 with that percent symbol, 2, 5 divided by 2, and the remainder after that is just 1. Let's do 6% 2. So 6 divided by 2 is 3 exactly, and there's no remainders. Let's try a different one. Let's say 9% 3. Modulo 3 if some people want to call it that. So 9 divided by 3 is 3 exactly, so there's no left over. 10 modulo 3. So 3 times 3 is 9. So that takes us to 9, but we have 1 left over. So that's 1. So in our examples, if I had a sum of 180% 360 will still give me 180 because there's nothing left over after I divide by 360. If I grow that number bigger to 359% 360, I still get 359. Now 360% 360 modulo 360, that's now 0. So 360 divided by 360, keeping the remainder, takes me back to 0. 361% 360 gives me 1. 362% 360 gives me 2. So you can see how if I have a circle and I'm adding up my angles and growing bigger and bigger and bigger, I start again at 0 here, see? 0. And then if I carry on round, if my sum of angles gets bigger, by doing a modulo 360, I can wrap the numbers to start again at 0 again. So that's all that is what this does. It means, in simple terms, if my sum here gets bigger than 360, I start again at 0. So let's see the effect of that. Much better. So you can see already those two really are clashing complementary opposite colours. Let's run it again. There, exactly. Complementary clashing colours. And that can be useful if that's what you want to do in your designs, to pick two colours or have a colour and find its opposite. You can do that. You can easily, using this HSB colour model, just find the opposite colour simply by moving to the opposite side of that colour wheel. It's lovely, isn't it? It's really nice. I have some code where which I've written before, I think this one here. Now it's if I increase that text size a little bit so you can see what's going on. You can see I've picked the HSB colour mode. I've chosen a very thin outline for the shapes. I'm actually using a repeat loop with a counter, and I'm going to be drawing circles along the screen using that counter. And the two hues I'm going to be using, the first one is a random one, and the second one is going to be wrapped around but added 180 to it. Didn't need that, did I? That one there. There you go. You find bugs in your own code. Let's run that. There, lovely. A series of circles with circles inside them, and the two colours used for the outer and inner circle are opposites. Let's go back to our code to find out where that's done. There you go. First hue, a random angle on that colour wheel. The second hue is the first one, adding 180 to get us the opposite, checking it hasn't gone over 360, and if it has, give us the remainder, and then drawing those two circles. quite nice, isn't it? So there's some, and you can see they definitely are clashing, and it creates quite a nice dynamic composition. You know, these are opposite colours if that's what you want to do. Brilliant, excellent. So another great thing about this colour model, it's easier to find opposites. You can take another pause now before we carry on to the next section, where we'll look at another way of using that colour wheel. Okay, so let's carry on. This time I'm again looking at a colour wheel, and I'm looking at, say, this yellow here, but instead of looking at the opposite colour like I did before, I'm looking at the colours that are near it. So if this is at 60 degrees, the colours that are near it have similar angles above and below. So this one here is 30 degrees less, and this is 30 degrees more. Now, these aren't opposite colours, these are not complementary colours. They're analogous colours, as they're called in colour theory. They're similar, and creating designs with similar colours has a much calmer result. Let's try that. So let's go back to our code. Let's draw 3 circles this time. So we're not calculating the opposite hue now. What we're going to do is we're going to say hue 2. Let's pick that one as hue 1, or hue start, and hue 2 is the first one plus, let's say, 10 degrees, and the next one is hue start, get the right name for it, and the hue 3 is the starting hue but less 10 degrees. So what that means is if we find a colour here, let's say yellow, we're going to pick another one which is 10 degrees below and 10 degrees above. So we've got those, and we're going to draw these circles. So let's draw the middle circle with that starting hue. Hue start, and then this one will be the one that's hue 2, and this one hue 3. Let's see the result. What do we expect before we run it? Let's have a think. Well, the middle circle will have a random hue, and it's going to be drawn with full saturation and brightness. Okay. The larger one outside it, the outer ring, will have a hue that's similar but a bit larger, and the inner one will have a similar hue, but that's just a little bit lower in angle. So I'm expecting to see similar colours. Let's see what happens. Yeah. So these are 3 similar colours. Let's run that again. They're a bit too similar, aren't they? There's some difference there. So this way you can create almost a colour palette of related colours. Let's run that again. Now they're almost too similar. So what can we do to change that? Well, we can increase that jump up and down. So let's go back to our picture. We started with a colour, could be yellow, could be blue, could be green, and we move away from it, not by 10 degrees but by 20 degrees, so we're still close to it but just a bit further to make that difference a bit more apparent. Let's see. Yeah. So these are not contrasting colours in the sense that they're opposite. They are analogous colours, similar to each other, and therefore the result is much calmer. They're not clashing with each other. Let's increase that distance to make them less similar, but not too dissimilar. I mean, we're not going to the other side of the colour wheel. Yeah, okay, so we've moved away from the starting colour enough to create a different colour, but again, they're close enough for there not to be a clash, so they're quite harmonious in some sense. Yeah. Now, circles aren't the best way of showing this, so again, I've written some code before. You've seen the result already, which just draws triplets of rectangles, and the middle rectangle has the randomly chosen colour, and the one to the left and right is just a bit further around and a bit below on the colour wheel. Let's you might be thinking I'm cheating because these colours do look more harmonious. Well, let's have a look at the code. One thing I've done is I've turned down the saturation and brightness a little bit. So if we go back to our own code, let's see what effect that has. So we had a saturation of 50, and what was the the brightness was 90. So if we turn that intensity down a bit, we can start to hopefully see the colours are a little bit more, calmer, much calmer. That really, so we're not cheating. It creates a much calmer. Oh, that's lovely, isn't it? Yeah, I like that. I almost didn't have to go to those rectangles. See, that's lovely. I'm really enjoying this. So these are really calm compositions of colour that are similar to each other. They're analogous. Oh, I'm really enjoying this too much now. Lovely calm colour kind of comparisons. Really nice. And all we did was turn down the saturation, turn down that intensity a little bit. Lovely. Really nice. So you can see again how this HSB colour model is useful for creating a range of colours, a colour palette for you to use in your own designs. These are really nice, I like that. So let's go back to that code for the rectangles, just to show that it's not cheating. So I've got simple setup, colour mode, HSB, and I'm again using a loop with a counter that draws a series of stripes. And there we go, the 3 instructions for drawing a middle rectangle, and one to the left and one to the right. So you can see there, actually what I've done is I've picked a point at X, and then I've drawn one to the right of it, and then again to the right of that. So X plus 25 and X plus 50. So that gives me my 3 rectangles, and here you can see I've picked a hue at random. Well, not at random, I've chosen a deliberate colour range there. I was doing that to make sure I didn't go wrap around the colour wheel. We can change our code to not have that restriction. Let's do that. 0 to 360. And then I'm picking related hues, which are 15 degrees less and 15 degrees more. And because I might end up going above 360, I now need to make sure I use that modulo, that remainder function, because I had previously limited my range for picking the random hue. I didn't need to worry that it was going to go over 360, so this should still work. Yep, my hues, intensities turned down. Yep, let's run that code. Here you go, lovely. What a beautiful composition. Really nice. So lovely kind of blues which are related, or pinky reds that are related, oranges. And this one here, this yellow is starting to veer off into the green, but it's still a yellowy green. Lovely. You could really enjoy this loads, couldn't you? Fantastic. Oh, I love that. Really nice. A lovely calm composition. So we'll stop there. We've done quite a lot actually, all in one long video. We've introduced this new way of picking colours called the HSB colour model. It's a colour wheel, and it allows us to pick colours around the circle and turn down and up the saturation and brightness. And it has some properties which are really advantageous to us. We can pick opposite, complementary, competing colours to create dynamic compositions, and you can see how that can be useful if you're calculating code, calculating colours. And if we don't want anything quite so contrasty and dynamic, we can choose analogous colours which are near each other on the colour wheel. So as long as we can get over this idea of colours being an angle around that colour wheel, there's quite a lot that opens up to us. The best thing to do again is have a play, have an experiment, and if you're curious, you'll find, if you kind of search, there are actually lots of other colour models out there, not just RGB and HSB. In fact, why don't we take a sneak peek? I think that's the website, Colorizer. Yep. So it's actually got quite a few here, if you're interested. So red, green, blue is the one we're used to. So we turn up red, turn down the other two, we get a nice reddy colour. Start turning up the green and we end up with a yellow. Now as we do that, the other colour models also start adjusting themselves. And we were using HSB, hue, saturation, brightness, and some people call that HSV, hue, saturation, value. And you can see the first number here is the hue, which is like that rainbow of colours around the colour wheel. There's something else here called HSL, which is related and not to be confused with HSB. Hue, saturation and lightness, and it just treats the brightness differently. So here in HSB, the saturation, turn that down and we end up going towards white. Turn down the brightness and we end up going towards black. Not in the HSL, on that one, turning down the saturation ends up with grey, and turning down the lightness goes from black all the way up to white. So it's slightly different, but I think HSB is much more intuitive, and there's a reason why it's popular. CMYK, you might have heard of that, particularly if you've been buying inks for your printer, because unlike displays, electronic displays, which use red, green and blue lights, the printing process, pigment, has traditionally used cyan, magenta, yellow and black, key for black, and it's a different way of mixing colours. Now earlier I almost caused some confusion by suggesting that you can't pick colours that are going to work in all these models. That is true, but for most purposes you don't need to worry about that. But if you're going to be printing and you're serious, and maybe you're printing a book or a poster and the colours have to look right, that's why you have to sometimes check that when a CMYK printer that's going to mix cyan, magenta, yellow and black, to make sure it can actually arrive at the colour you want, because you've done the colour on a electronic display which mixes red, green, blue. And there's more colour models here. I should have said that we still have translucency and that can still apply. Let's go back to our code. So if we added a fourth number, it actually goes from 0 to 1 now rather than 0 to, is it 100? Yeah, it's 100. So let's say 50, 50, 50. Can't easily see that they are transparent there. Maybe I got that wrong, maybe it's from 0 to 1. Yeah, that was it. So if I make 0.9, that means it's not that translucent. There. So the alpha value, the translucency value, goes from 0 to 1. And that can be useful as well, although in this particular composition you can't really see it. If I move one of those circles to the left, you might be able to. Let's try that. There you go. Yep, you can see it see-through. Lovely, we've had quite enough fun today. I hope this video was useful in introducing this new colour model, this HSB colour model. It's worth persevering and trying to kind of understand it and play with it and experiment with it, because it is so beneficial in terms of calculating colours and creating kind of colour palettes, that many digital artists end up using this instead of RGB. So I would really recommend getting familiar with it, and the way to do that is by experimenting and playing. We might do another video, a short one again, just to pick a small example, just to help us kind of understand a little bit better. But for now, I hope you have fun with that. See you next time. Bye.